So here we have a problem about gravitation between the Earth and the Moon, and we're going to use Newton's gravitational formula to figure out what is the force of the Earth and the Moon on each other. To do that, to apply this formula over here, we need to know what g, the gravitational constant of the universe, is, and the mass is how much material each body has, and then r is how far they are apart. So we're given all that information here. Given the size of these numbers, it's going to be easier to type in scientific notation. So we're going to first convert to scientific notation, ensuring we have the right units, and then we'll make the calculation. So a thing to note about this formula in the order of operations, we essentially have a multiplication here followed by another multiplication here, and then divide by the square of r. And multiplication is supposed to be done multiplication and division as a group are supposed to be done left to right. So another way to think about this formula would be that the force is equal to the gravitational constant times the first mass times the second mass, and then divide by the square of the distance. So that's the way I'm going to enter it into my calculator. When I square that distance, it's going to be a scientific notation number, so I'll have to put that part in parentheses and then square it. So let's make our conversion. This here says kilometers, and this is meters, and kilo literally means 1,000. So that's really 384, 1, 2, 3. The 1,000 gives us another 1, 2, 3, and that would then be in meters because I replaced kilo with 1,000. And then I want to move that decimal point 1, 2, 3, 4, 5, 6, 7, 8 places. So this should be 3.84 times 10 to the power 8 meters. Next, the mass of the moon here in kilograms, the units match. I need to move it a bunch of groups of 3. So how many? 1, 2, 3, 4, 5, 6, 7 groups of 3. So that'd be 21 places, and then one more place. Because in scientific notation, you can only have one digit to the left of the decimal. So this would be 7.348 times 10 to the power 22. Next one is the mass of the Earth. Kilograms, kilograms, that's good. And then count the groups of 3. So we have 1, 2, 3, 4, 5, 6, 7, 8 groups of 3, so that'd be 24 places to move that decimal point from the imaginary spot there all the way to right between the 5 and the 9. So 5.9722 times 10 to the power 24. So those are the values I need to plug in along with this one right here to calculate this force. So I'm just going to write that out here. So I'm going to take the 6.674 times 10 to the negative 11, multiply that by, let's see, mass 1, the moon, 7.348 times 10 to the 22nd, multiply that by mass 2, that would be the Earth, 5.9722 times 10 to the power 24. Then I'm going to divide, and I'm going to use an extra set of parentheses because this number is complicated and the whole thing needs to be squared. So I'm going to have a parentheses for that and then square it. So that would be the 6.674 times 10 to the, ooh, wait a minute, wrong number. I already did that number. That would be this one over here, I see. Sorry, the distance. Oops. Thanks for letting me know. I heard you out there in the future. So try that again. 3.84 times 10 to the 8th goes there. And then that whole thing has to be squared. Without the parentheses, only the 10 to the 8th would be squared, but not the 3.84, which would screw things up. All right, so now I got to get that into my calculator. So let's go to my calculator screen here. And I think I'm going to split the screen so I can see the problem and get the numbers right. All right, so here's the original problem. And let's adjust a little more right there. All right, so big calculator here. So where do we start? We started with the gravitational constant here in our formula. So that's going to be 6.674 times 10 raised to the negative 11. That gets multiplied by the moon, which we decided was 7.348 times 10 to the power 22. And that gets multiplied by the mass of the Earth, 5.9722 times 10 to the power, we counted 24 places, divided by, here's where I need the parentheses, and that was the distance. So 3.84 times 10 raised to the 8th, and then I need to close the parentheses and square it. So then square that. Okay. Hope it's right. We'll double check in a sec. Equals. My calculator says rounding to 3 significant figures, 1.99. E on a calculator means times 10. Sometimes your calculator has a lowercase, sometimes an uppercase. And then the next thing is the power, positive 20. So I'm going to write that down and then double check I did this right before I hit check my answer. So I believe the result of that whole calculation is 1.99 times 10 to the 20th power. All right, so a couple ways to double check this. Just reading the directions again, it's got to be in scientific notation. Got that. This number right here has only 1, 2, 3 significant digits. Zeros don't count there. So they're saying the answer should only have 3 digits. And so there's my 1, 2, 3 significant digits. The rest are a bunch of zeros. All right, double checking the powers. When you multiply things with powers, they get added. So negative 11 plus 22 is 11. Plus 24 is, 36? And then this would be 10 to the 8th to the second, which would be the 16th power. And if you divide things with exponents, the exponents get subtracted. So 36 minus 16 is 20. Hey, I got the 20th power. So an estimate of the power works out here. So that's a good sign. Okay, that looks good. So double check what I typed, and the computer is showing it to me up here. Hopefully you can see that. I can blow it up a little more. And it's nice to have a calculator that shows what you typed. And if you don't have one, then I'm sorry to hear that. But I'm just typing into the Google calculator. All right, so 6.67 times 10 to the negative 11th. Is that the right number? 6.67. Oops, show desktop again. 6. Oh, I missed the 4 on that. Oh, darn, I don't feel like retyping all of this. All right, so I got one typo there. I must have hit the key, but it didn't record. Not hit it hard enough. Okay, 3.484. 7.348. Man, did I read that wrong? Where's that one? 7.348, and then 5.9722. Oops, where'd you go? 5.9722. Okay, so I just made one, and then 3.84. Yeah, I just made one typo over here. I missed that 4. I don't think that's going to matter much because that's in the 3rd place in here. But I probably should retype it to make sure. Darn it. All right, so one more time. 6. Oops, I got to zoom out on my calculator for a sec and look at the numbers, make sure I get them right again. Yeah, always double check. Remember, on homework you have this submit question to check your answer, but on a test you don't. So you need to get good at checking your own answers. So trying again. So if you already got it, then feel free to close this video and move on. 6.674, there's the 4, times 10 raised to the power negative 11, okay, times 7.348, no, times 10 raised to the 22nd, times 5.9722, 5.9722 times 10 raised, we counted 24 there, and then divided by parentheses, 3.84 times 10 raised to the 8th, close parentheses, then square that sucker, and hopefully we get about the same number. Yeah, there was a 5 here, 50, now it's 62, so we're in the ballpark. So it's still 1.99 times 10 to the 20th. I just had a typo. So here I can go my 1.99 times, and notice until I complete the scientific notation, it says, hey, something's wrong. 10 raised to the 20th. And down here, it's telling me use scientific notation, and I can get more information about what that means and how to type it. All right, and I'm not going to worry about the other numbers at the moment. Hopefully you will. And cool, I got the hard part right. All right, take care, do good math. Try not to mistype things too much.